Good evening. Happy Monday. We looked at disk method on Wednesday, right? Shell method today. But you have an assignment due today. So let's go ahead and turn that. Right, we're looking at shell method. It's recalled disk method. The independent variable had to match the axis of revolution, right? So if it was a horizontal axis, it's an x-axis, so independent variable had to be x. Vertical to y-axis, so you have to write it in terms of y. Fx is continuous, obviously. We rotate the region under f of x. So it should be noted f of x again is positive for that interval. So rotating the region below f of x about now the y-axis gives you a solid revolution whose volume is given as 2 pi times the integral from a to b of x times f of x dx. So notice, rotating about the y-axis, independent variable is x. So for the shell method, you use the opposite independent variable. Rotating about the y, you're writing it in terms of x. If you rotate about the x, you write it in terms of y. So this is going to be used for the function is really complicated, right? You cannot solve it x in terms of y. Another way it's going to be written that's how I'll typically write it, r times h. R has the same meaning. It's the radius of the solid. So it's measured from the axis of rotation to an arbitrary point in the solid. An arbitrary point in the region. H is the height of the region. I call that region R. Rotate about the Y. That's R, which is X. So as long as you're rotating about the Y-axis, your R is always going to be X, right? Because it's the distance from the axis to the point. Well, that distance is whatever the point happens to be, right? Whatever the x-coordinate happens to be, x. And that varies, obviously, as you move along the interval from A to B. But if you imagine an imaginary horizontal vertical line here, the x value along that line is always the same, right? So really all you're dealing with is it doesn't matter where in terms of verticality, it just matters in terms of horizontal where you are. And so an infinite number of points, but kind of like half, because you only have one dimension you have to worry about. And then the height is just the height of the region. And so you'd imagine now if you have a region bounded by curves, how that would look. And generally speaking, that's going to be f of x. Right, that's the function. So I should technically draw that out. You pick a point, and then how high is it at that point, and what's the radius at that point? What did they do with this board? So we're going to revisit the problem from Wednesday. We're going to plot this region again. And then we will again find the volume of the resulting solid when it's rotated about the y-axis. But this time we're going to use shell method. Remember on Wednesday we did it and we used disk method. just heads up, I'm going to apologize in advance. I finally found the time to start learning Python. So if I mix up the languages, that might happen. So I might type it in wrong because I'm now learning Python, so I might use the Python language instead of Wolfram. This will be fun to try and keep everything straight. Good news is I do have my reference. We're again going to start just simply by plotting x cubed, right? Let's go -5 to 5 and set the plot range -5 to 5 as well. So it's again implied we're also going to be bounded by the y-axis because we're going to restrict our region to be positive. All right, so we're looking in here, and it's the line y equals 2, right? So we're going to be looking inside here as our region. Don't want to do that. Okay, I don't need to. Okay. We're just going to go from 0 to 2, right? Because it's bounded by the y-axis and the line y equals 2. It's also bounded by the x-axis and the curve x cubed. Plot range should be fine. The default range that it gives should be fine. I'm going to change my plot style. It's not between two curves, right? It's just between one curve and the axis, so I'm just going to use the axis option. I'm also going to set the seed. What is it? Forget what I used last time. Seed random. Yeah. And then set that as empty. I don't actually need to execute that first. When I execute the entire code, it will do it, and then use that random seeding. Zero and 256 divided by that should be all I need. Right, so there's our region, right? You're rotating about the y-axis. What is the radius?
2?
It's just x, right?
Yeah.
What is the height?
8. That's like 8.
Well, it's at x equals 2. The height's 8.
Yeah.
That would be x cubed.
Yeah.
Right, because remember what we're doing is an arbitrary point in the region. The radius is the distance from the axis of revolution to that point. Well, arbitrary point is going to be given by x. And then at that point, what's the height? Well, it goes up from the x-axis to the curve, which is x cubed. At that arbitrarily chosen point. Right, because remember the idea, and again, watch the video for the derivation, but the idea is we're summing over an infinite number of points. Right, so it's not just a single radius and a single height we're using, right? It's an infinite number of radii and an infinite number of heights that we use. Volume is then 2 pi integral of the radius times the height. What are the intervals, or what are the limits of integration?
0 and 2.
0 to 2.
Yeah.
This boils down to just 2 pi times the integral from 0 to 2 of x to the 4th. Two pi over 5x to the 5th from 0 to 2. 2 to the 5th times 2 is 2 to the 6th, which is what?
2 to the 6th is 64.
You get 64 pi over 5, and compare that with what we did on Wednesday.
Yeah, it seems a lot shorter.
It's the exact same volume. We just have to worry about converting it into a function of y first. Is it always easier to use shell method?
Probably not always.
Well, difficulty is subjective, right? So I can't really answer that. However, I can show you a problem where we're going to do both shell and disk. And then you can decide for yourself for this particular problem which one you'd rather do. So I'm going to need the entire board for this. So we're going to be looking at what's called a polar cap. Right? So polar cap is just a so take a sphere. That would be a polar cap. And so think of the Earth, the two polar caps we have. That's literally what it is. It's just either upper or lower portion of a sphere. Right, because I could also have it down here would also be a polar cap, right? If I look at this region, that would also be a polar cap. That's how we can form it. Take region in the first quadrant inside of circle of radius r. So if our sphere is radius r, we just take a quarter circle of radius r, the first quadrant quarter circle, between y equals a and y equals r. A is some positive value in this case. So first I'll draw the region. I'll say draw, I'll sketch the region. And then I'll show you how we could do it using Wolfram. So we take the quarter circle, good enough for government work. Let's call that y equals a. So this is our region up here. What would this point up here be? Yeah, so that's just r, right? What about here? Yeah, that's also just r. And we're rotating it about the y-axis. But to kind of visualize, right? You rotate this region about the y-axis, you get a polar cap. We call polar cap of a sphere of radius r. So how can we do this in Wolfram? I'm not going to be able to, well, actually I could. I can shade. So I think I will. So first we're going to go ahead and plot the quarter circle. Oh, here's the problem. Our circles of arbitrary radius, right? X squared plus y squared equals r squared, so we need a function of x, right? So y equals square root of r squared minus x squared. I'm going to start there. Right, positive because we're in the first quadrant. However, it's not going to be able to work with that. Just pick an arbitrary value for r.
3.
We already saw x is going to go from 0 to what?
So R.
So there's going to be a little bit of a problem doing it this way with the filling. I won't worry about the filling just yet then. But again, we said r was 3. And what I actually need to do is I need to add in a second function. Because I need to add in that line y equals a. But again, it can't work with that. So pick an arbitrary value for a that makes sense.
2.
2, yeah, that's what I was thinking. If r is 3. and replace it with 2.
It would have to be something less than R, right?
Yes. And you want it also to be somewhat close to R. Right, so 0.5 would be a pretty large polar cap.
Like,
Plot range should be good. I shouldn't have to worry about setting that. And what I'm going to do is I'm going to, of course, just set the plot style to black. So if this is what I stop at, this is what it's going to give, right? And then our region would be this region here. But now this isn't arbitrary because we have exact values. I can fix that. First thing I want to do is go ahead and label my axes, X and Y. Right, so I'll show you what that does. Just literally adds labels for the axes. And it can be whatever you want it to be, right? So if you're doing a time, like if you're doing a graph in physics, right, position, time, you can just type in, again, in quotations to show that it's text, right? It's a string. All right, now you see the x-axis is being labeled as position, y-axis is being labeled as time. So when you go with the axes label, it's always going to be x, y, and if it's three-dimensional, z. So whatever you want to label your x-axis, you type that in first. Whatever you want to label the y, you type that in second. Whatever you want to label the z, you type that in third. Now, for purposes of this problem, I'm just going to set it to x and y. But that still leaves the problem if it's giving me these values. Do you remember what these are called when you studied graphs and probably algebra? They're ticks. I can adjust the ticks as well. So you can make the ticks whatever you want them to be. Right, so they have to be in double braces. Not technically double braces, right? You need outer braces. And then what you do is the first set of braces are the X ticks. So I could just go, if I wanted, 1, 2, 3. Comma, and then Y ticks, I can just go 1, 2, 3 again. Close them out. And now it's only going to show 1, 2, and 3 along the X and 1, 2, and 3 along the Y. Right, and again, adjust it however you want to adjust it. Right, if you're working with trig, you can do multiples of pi over 4 or multiples of pi over 2, whatever you want, along the x-axis. Because I want everything to be arbitrary, I'm going to set my ticks to none. Now there are no values. Everything's completely arbitrary. The only problem is you have no way of now putting down, like, this is the line y equals a, this is r and r. You need the desktop version of Wolfram to do that, which unfortunately you have to pay for. And they only offer it as a yearly license for students, $175. Or you could pay $390 and have a lifetime license. But again, that's not needed for this course, so this will be fine. If I wanted to do that shading, I would have to find that point of intersection and then do a separate plot from 0 to that point of intersection and then shade and then show the shading on this plot. I could also not even include this line on the original plot. I could just include it on the shaded plot so that the line doesn't extend out further. I'm going to start with shell method. So remember, this line is line y equals a, and this circle is x squared plus y squared equals r squared. Radius. And so we pick a random point. What is that distance? It's just x, right? Uh-oh. At that point, that's the height. What is that height?
Y minus A.
R minus A. It's not R minus A, it's
So,
Function minus A.
yeah, it's the function minus a.
yeah.
What's the function?
X squared plus y squared.
That's not a function, right? That's just an equation.
Yeah. So we need to do this back to x.
Yeah, so you need it as a function of x.
So square root of y squared minus r squared. R squared minus y squared.
You don't want a function of y.
Well, yeah,
You
but
want a
you
function
get
of
x.
x.
But you get an x by itself, right?
No, that's a function of y. You want to solve for y.
Oh,
That gives you a function of x.
so it's actually the square root of r squared minus x squared. Alright, so-
Minus a. So technically what we're doing is very similar to the washer method. Because I could just define two heights. Right, my outer height, which would be from the x-axis to the curve, which is this. And then my inner height from the x-axis to that line, y equals a. And then subtract the two volumes. Right, so what we then do is find the volume of the sphere, of that half sphere, and subtract the volume of whatever the hell the shape is when you rotate it. But because it's just simply, when you look at the volume, r times h, you don't have to square h like you did with washer method, you can just calculate a single height this way. So it doesn't matter. Volume would be 2 pi times the integral r times h dx. Limits for integration, 0 to whatever that point is. For now, I'm going to call it x naught. I need to find a value for x naught. Well, it's going to be that point of intersection, right? So what we're going to have to do,
Yeah.
set the functions equal to each other. Solve for x. X squared is r squared minus a squared. So what is x?
Square root of r squared minus a squared.
Why?
That's how you would, that's how you get x by itself.
Is the square root of x squared x?
Or negative x.
So why is that correct?
Because we don't have positive x.
We're in the first quadrant. X is positive.
Yeah.
There's the x coordinate for that point. So 2 important notes. First, radius is always greater than 0. That's important. They also told us, which again, makes sense, A is positive. It has to be, right? Because we're in the first quadrant. So A would have to be positive. Both of these are important to keep in mind as we go through this evaluation. That's the integral we have to evaluate. Distribute the x through. If you look at this first term, what is the derivative of r squared minus x squared?
2r minus 2x.
R squared minus x squared.
Are one of them a constant?
Mm-hmm.
R is the constant?
Mm-hmm.
So then it's just 2x, negative 2x.
It's negative 2x.
Yeah.
Oh, look, I have an x. This is u sub. I'm going to need a negative 1/2. U to the 1/2 has antiderivative what?
Two-thirds u to the 3/2.
There's your first antiderivative. Minus. That's that second antiderivative.
It's a is a constant.
Mm-hmm.
Just A. Right. Oh, you say antiderivative.
Antiderivative.
AX squared over 2.
Yep. So I'm going to write it as a over 2x squared. And then that gets you value from 0 to the square root r squared minus a squared. So I'm going to take care of some simplifications. 2 pi. 2/3 times a half is a third.
Sounds negative at, right?
Mm-hmm. I'm going to factor out the negative and flip the order in which we evaluate. Right? And ultimately what that means is, because remember, if you flip the limits of integration, you multiply the result by -1. So that's all I did there. I got rid of that negative because there was a negative in both of them. Now for the fun part. Evaluating this bloody thing. At 0, you get r squared to the 3/2, right?
Yeah.
So square root of r squared is absolute value of r cubed. But r is positive. So we can just write that as r cubed. Don't need the absolute value. Now, at square root of r squared minus a squared. Well, x squared just becomes r squared minus a squared, right? So r squared minus r squared is 0. Minus negative a squared is positive a squared. All raised to the 3/2. So a squared to the 3/2. Square root of a, or square root of a squared? No, it's not. It's absolute value of a.
But A is positive.
But a is positive.
Yeah.
So that does just become a cubed. That's why I said it's important to keep these two facts in mind. If they were not given, they'd have to be absolute values. Which if you type this integral into your calculator, it does give you absolute values. Right? Because it doesn't know that R and A are positive. Plus, okay, so that takes care of that first term. Well, look, at 0, that's 0.
Yeah.
So, minus a over 2 times r squared minus a squared, right?
Shouldn't it be the square root?
Right, but x is being squared.
Oh, okay, yeah.
That's technically acceptable. But we can clean it up a little bit. First thing, I'm going to get rid of fractions. How do you get rid of a fraction? So glad you asked. Factor out the common denominator. Factor out 1 over the common denominator. Factoring out a 1/6. Two pi over 6 is pi over 3. This becomes 2r cubed, right?
Yeah. Minus.
I'm going to go in decreasing order of r. A over 2 would become 3a times r squared. Plus 3a cubed. Minus, though, that's what, 2a cubed?
Yeah.
So it's just plus a cubed. There's the volume of a polar cap. Right. So in this case, you think of the polar cap, the sphere's radius r. Your A would just be, okay, well, how high off the center of the sphere is the polar cap? That's your A. And then that would be your formula. That would be your formula for the volume. That was a lot of work. Let's try disk method and see what we get. For disk method, there's only one variable I need. R. Well, remember, R is from the axis of revolution to the curve. In this case, right, because if you look, the region isn't being split between two curves. Right, at least if you're moving through it horizontally, right? It's a single curve from the axis of revolution. What's that curve in terms of y?
Should it still just be the function
What's the function?
of radical r squared minus a squared?
Minus what?
Y squared?
Minus y
Y
squared.
squared, yeah.
Because I need a function of y, and I just realized I probably should have been using like r prime or something to differentiate it from the radius of the sphere. Or maybe I should have used a capital R for the radius of the sphere. Whatever. Volume would be pi times the integral of r squared dy, and what are the limits of integration?
Zero.
Remember, integrating with respect to y. It's a to r, isn't it? Because the region doesn't start until a
Okay, it's at r.
and ends at r. Because remember, we're integrating with respect to y.
Okay.
So what does it cover along the y-axis? A to r. Well, that certainly looks a hell of a lot easier than that integral, right? What is that antiderivative, r squared with respect to y?
1/3 r cubed.
With respect to y?
R is constant.
The radius of your sphere is unchanging,
Okay.
right? Once you have a sphere, it has a fixed radius. It doesn't change.
Also, r squared is just a constant.
Yes.
Okay.
It may be unknown, but it's still a constant, right? It's
Okay.
unchanging. What is the antiderivative of y squared?
That will be 1/3 y cubed.
That gets evaluated from a to r. So pi times r squared minus r squared times a. And again, convention is you write it, if you have a bunch of variables, you just write it alphabetically. So that'll just be minus ar squared, right? Minus 1/3 r cubed minus negative plus 1/3 a cubed. If I just combine, actually, I probably shouldn't be using that. How do I want to do this? To signify to only those two. Maybe that, I don't know. If I just combine those two values,
Should be 2/3 r cubed, right?
I'm just going to write that as like a little side note to myself, so I'm not wasting another line. Oh, well, this one's even easier. Just factor out 1/3. Two-thirds r cubed becomes 2r cubed. Minus ar squared, we're factoring out a 1/3. That just becomes minus 3ar squared. Plus, factor out a 1/3, you're just left with a cubed, and there's your volume. Which is exactly the same as what we calculate with Shell method. Which it should be, right? They should be the same. One was less complicated, let's say that. In this case, even though it was a y-axis of revolution, the disk method was less complicated than the Shell method. Is there a way to tell that right off the bat without doing any work? Yes. It's called do it for 20 years. And they'll just see immediately that the disk method is less complicated because of the setup. Right. Not the answer you want, but unfortunately that is the answer. Do it long enough, you just kind of see it. Stop trying to kick me out of the session. So plot region in the first quadrant bounded by the two parabolas, 2 minus x squared and x squared. Let's start with that. Yeah. First, I'm going to start with just plotting the parabolas. First one was 2 minus x squared. Second one was x squared. I'm in the first quadrant, so I'm just going to go 0 to 5. Let's just see what that gives us. And I'll set the plot range to be the same. See what that gives us. Perfect. What region are we dealing with?
A y-axis intersection.
Saying this one?
Or the one on the bottom. Yeah. Can we see the assignment one more time?
Which one is it?
Doesn't matter.
It does matter.
In terms of y.
The correct answer
The bottom.
is this one. Because that's what my source used. I think it's implied to also be between the y-axis. Have the y-axis as a bound. So you need that as well, and the line x equals 0 to know it's that region. If it was y equals 0, then it would be this one. It cannot be both of them. Because then you don't need this yellow line and you're no longer bounded by 2 parabolas. So you can only have one of them, and it depends on the last bound. So I'm going to go and fix that. Now we can clearly see that this is indeed the region I want. which means along the x-axis, I need this point of intersection. It appears to be 1. Let's verify that. It doesn't look right. It was okay. 1. Bah. Those are going to stay the same. That becomes 1. I don't need the plot range anymore. Default should be fine. I'm going to change that instead to plot style just to make them both the same color. Filling. It's between 2 curves, right? And then filling style. I don't even need that. I'm going to go up. Copy it. Oh, and I forgot the RGB. Oh, of course I did. So now I'm going to have to add that back in. Okay, whatever. There is one other thing I want to do. I'm going to actually label the curves so I know which one is which. And remember, that's being rotated about the y-axis. So it's going to be, okay, UFO kind of thing. Oh, I'm sorry, they're not UFOs anymore.
What are they? This? One.
They're UFPs. Unidentified flying phenomena. That's what they call them now. We don't call them objects, we call them phenomena. Because object makes it sound like it is actually like something from outer space, and phenomena is like, you know, it could just be something in the atmosphere that we haven't identified. Of course, UFO could also just be something from a foreign country that we haven't identified. It could be anything. It could even be a US drone that just isn't identified at the moment. That's a UFO. Two quantities we need. We're going to need an R, we're going to need an H. Because we're going to use shell method. Well, radius should be simple. Radius is just x. What's the height?
It looks like me too, but oh, it's a function.
Upper function minus lower function?
Which would be give you what?
The height.
Yeah, so what is it? When you take the upper minus the lower, what do you get?
2 minus 2x squared.
2 minus 2x squared. It's 2 minus x squared minus x squared. Right? The upper function, 2 minus x squared, minus your lower function, x squared. We get x, right, radius times height. What are the limits of integration?
This is with respect to x or y.
With respect to x.
Look at 0 and 10.
0 to what?
0 and
0 to 1.
Okay. Oh yeah, horizontal.
This becomes very simple. Antiderivative 2x, x squared. Antiderivative of 2x cubed, 1/2 x to the 4th. That goes from 0 to 1. This is really simple. That's just 1 minus a half, which is a half.
Yeah.
Times 2 pi.
It's pi.
Volume is pi. There's my mouse. Find the volume of the solid obtained by rotating the region bounded by the parabola for y equals 4x squared, and the lines x equals 0 and y equals 16 about the line x equals -1. Now it's not an axis. So let's plot this region first. Let's see what it looks like. First curve was y equals 4x squared. Then we're told it's between the lines x equals 0 and y equals 16. Well, x equals 0 is just the y-axis, right?
Right.
I am going to plot the line 16, just so I have it. I don't technically need to go to the left of the y-axis, so I can just start x equals 0. Let's go out to 5. Let's set the plot range to be 0 to 16.1. For x squared is never going to be below the x-axis, is it? So that's why I'm starting my range at 0. And I know that it has to be bounded also by the line y equals 16. Well, the problem is I don't know if the region's going to be above or below. Well, actually, I do. Just by looking at it, you can tell that it's going to be below y equals 16, right? Because it's 4x squared. That should be good. So it's this region in here. Gonna need that point of intersection. Well, this is easy enough to do in your head. 4x squared equals 16. What's x?
4.
2.
2.
Oh. Yeah, 2.
X squared is 4.
Yeah.
I'm going to start with the axis of revolution. So it's the line x equals -1, which means I need to use contour plot. Plot only works for y equals f of x. X equals -1. Let's set x to be -1.1 to 2. I'm going to go out just a little bit further, 2.1. Y, 0 to 16.1. There's a reason I'm going just a little bit beyond what I need. Just so I can guarantee that I can get the region to actually fully show on the axis. I'll do what I did last time. I'll set the axis to be red and dashed. So that's contour style. And directive. I don't actually need the directive. I could actually just put red dashed in braces. But then if you have multiple plots, I have multiple curves, then you have to wrap each one of those in their own separate braces. Whereas if you just do directive, right, then it's just saying that for that one plot, it's going to do everything inside the directive. It's going to set it to everything inside the directive. Because I can also make it bold if I wanted to. So I could do red dashed and bold to make it really stand out. That should work. Then the actual region. I'm going to copy that. That's going to stay the same. My domain's going to change. I am also going to set my plot range to just 16. That would actually allow me to get rid of this at this point. But I'm not going to. I'm going to keep it. We're between curves, so I want to fill between plots 1 and plots 1 and 2. And what do I want my plot style or my filling style to be? Let me come up here. And just copy that. I don't need the labels this time. It should be fairly obvious to tell which one is the parabola and which one is the straight horizontal line. That should be good. Then what I'm going to do is I'm going to show the region on the axis. Crap. Forgot about that. All right, so a few things I need to adjust. In here, I forgot to set my frame to false and axes to true. And here I forgot to set my plot style. All right, that should fix it. There we go. Rotating this region about this line here. We want the volume. Going to use shell method. We need a radius, we need a height. Radius is what?
Is it x plus 1?
Y.
Because of the minus 1 instead of being at the, yeah.
Right.
Axis.
So the distance we want is from here to an arbitrary point in the region.
Right.
Well, we know from the y-axis to that point is x.
So for negative.
From the axis of revolution to the y-axis, that distance is 1. So the total distance between the axis of revolution and that point would be the sum of the two, x plus 1. You could also, in this case, shift the axes to the left 1. Notice that would change then your radius. Your new radius would be x plus 1, right? Move to the left, so you add 1. It would not affect the height. Would affect it a little bit. Because your function is going to change. It would no longer be 4x squared, would it? It would be 4 times the quantity of x plus 1 squared. 16 would be the same. Did I do it? I did do it this way. The radius wouldn't be x plus 1 at that point then, would it? Radius would just be x. Because I shifted everything over. So if I did it that way, yeah, the radius would then become x, but then your height would become something different. What's the height right now?
4x squared? Oh, we had to write in terms of like y or something?
No.
Just why?
So height of the region. You start calculating height from where? Here. And it goes up to what? There. So what's that height?
Let's go. Upper function minus lower function, yeah.
Which is what?
Y minus 4x squared.
What is the upper
Plus
function? It's not y.
16 minus 4x squared.
Oh, 16.
If I went the shifting route, that would become x plus 1 quantity squared. This would then become x.
That might make things a bit more complicated.
Because remember, when you shift along the x-axis, it's the opposite, right? If you shift to the left, you add. If you shift to the right, you subtract. All right, 2 pi times the integral. Radius times height. Limits of integration.
Oh, where is the x? Right. To 2.
0 to 2. The dreaded 4-letter F word.
You gotta boil that.
So let's go 16 plus 16x minus 4x squared minus 4x cubed. So I can write it in ascending order. Right, not descending this time because descending will start with a negative and I don't like negatives out in front. But again, it doesn't matter. You can write it however you want to write it. I'm just going to do this in my head. That's going to be 16 times 2. 16 times the length of the interval. Plus. That antiderivative is what? 8x squared? From 0 to 2? It's just going to be 8 times 4. 32. Minus. This is 4/3 x cubed. That's going to be what?
32 over 3.
32 over 3, right?
Yeah.
No.
Are you like taking the
Yes.
antiderivative and doing limits at the same time?
Not limits. I'm evaluating it after the antiderivative. Yeah, that's right. X cubed, 2 cubed is 8 times 4/32. Yeah. So minus 32 over 3.
Okay.
Because remember, at 0, all these are going to be 0.
Oh, okay. Oh, so you're taking the antiderivative
Yes.
and then evaluating.
And then evaluating that antiderivative from 0 to 2.
Okay.
I'm just doing it all at once. Because it's fairly simple to do. Right?
Okay.
That's going to be minus x to the 4th. From 0 to 2, it's just 2 to the 4th, which is 16. So I'm going to do this. 2 pi over 3, I'm going to factor out a 1/3. Right, because I have to do common factors. I have to do the common denominator anyway. First, I'm going to do 32 plus 32 minus 16, which is 32 plus 16, which is what?
48.
2, 16, 48. Now, 48 times 3.
144.
144 minus 32.
112.
No, 112.
Times 2. Yay! Did mental math correctly. 224 pi over 3 is our volume. Always a good feeling when you do mental math correctly. Questions on shell method? And then for those who came in late, do you have a project for me to hand in? No, okay. You can now work on assignment number 11, that is shell method. And we also have a quiz. Yeah, there should be two. There should be two there. So the second quiz covers everything since the exam. So just weeks 5 and 6. Started with area between curves. And obviously up through today, shell method. That is due on Wednesday.
Do you have a midterm next Wednesday? Or?
Not next Wednesday. The Wednesday after that's the 13th.
What, not this one?
Yeah, not this coming Wednesday. Not next Wednesday. Oh wait,
Next Wednesday.
this Wednesday's the 11th. That's right, yeah, it is next Wednesday. The 13th, next Wednesday. Which is the Wednesday before spring break.
Yeah, that's in person right here.
Yep, that'll be in person. Only be allowed to use a calculator. You won't be able to use like Mathematica.
No formulas?
You can use notebooks.
I can.
Yes, as long as the notebook's printed out. That will do it for this evening. So I'll see you again on Wednesday.